everyone, and welcome back to On The Spot STEM. Today, we'll be doing a speed run of 2016 AMC 10B to help you with your AMC prep. And so what I'm essentially going to be doing is, I'm going to be setting a 30-minute timer, a half-an-hour timer, and I'm going to go through as much of this test as possible in that half an hour. And for each problem, I'm going to explain how to do it, and I'm just going to run through it pretty quickly. I'm not going to go as detailed as we usually do in our problem videos, but this is a speed run, so it's more about the time. So without further ado, let's begin. Number 1, what is the value of 2a to the negative 1 plus a to the negative 1 over 2 over a when a equals 1/2? Well, 2 to the negative 1 equals 2 times 2 equals 4, plus 2 over 2 is 1 over 1/2 is equal to 10. Number 2, if n heart m equals n cubed m squared, was 2 heart 4 over 4 heart 2. Well, n heart m over m heart n is essentially what we want. This is the m cubed m squared over m cubed n squared. That simplifies to n over m, so 2 over 4 is equal to 1/2. Number 3, let x equals negative 2016. What is the value of absolute value of absolute value minus x minus absolute value of x minus x? So this is over here is 2016 minus negative 2016. So this part is 4032 minus absolute value. So this whole thing is equal to 2016, and then minus negative 2016 is equal to 4032. Number 4, Zoe read 15 books one at a time. The first book took her 1 day to read, the second book took her 2 days to read, the third book took her 3 days to read, and so on, with each book taking her 1 more day to read than the previous book. Zoe finished the first book on a Monday and the second on a Wednesday. On what day of the week did she finish her 15th book? So essentially, after she reads n books, it takes her n times n plus 1 over 2 days. And if n equals 15, this is just 120 days. And she starts on Sunday, since she finishes the first book on a Monday. So Sunday, and then 120 days after Sunday is what we want. Week cycle mod 7, so 120 to mod 7 is equal to 1. So it's just 1 day after Sunday, which is Monday. Number 5, the mean age of Amanda's 4 cousins is 8, and their median age is 5. What is the sum of the ages of Amanda's youngest and oldest cousins? Let's just let these ages be A1, A2, A3, A4, where these are ordered. So A1 less than A2 less than A3 less than A4. The mean is equal to 8, so their sum is equal to 32, all 4. And their median is equal to 5, so that's only A2 and A3 over 2. So A2 plus A3 equals 10. And that means, if A2 plus A3 equals 10, that means A1 plus A4 equals 22, since they all add up to 32. So that's the answer. Number 6, Laura added 2 3-digit positive integers. All 6 digits in these numbers are different. Laura's sum is a 3-digit number s. What is the smallest possible value for the sum of the digits of s? So essentially, we know that they're 3-digit positive integers, so they're greater than or equal to 100, and essentially that means that the sum is greater than or equal to 200, so the 100th digit is greater than or equal to 2, so 1 is already out of the picture, since that cannot be the sum. Now let's check if 4 can work. So we essentially want something like, since the sum of the digits is 4, which is small, we want something like 1xx and then 2yy or something, or x, y, and then za, because these are all distinct, and they should add up to something that has the sum of the digits of 4. So if we choose 400 to be the thing they add up to, then we can take something like 104 and 296, and that would work. So the B is the answer. Since if 4 works, and we concluded that 1 couldn't work, then it has to be the lowest that works. Number 7, the ratio of the measures of 2 acute angles is 5 to 4, and the complement of one of these 2 angles is twice as large as the complement of the other. What is the sum of the degree measures of the 2 angles? So essentially, if we let the angles be A over B, where A greater than B, A over B equals 5 over 4, and 180 minus A times 2 equals 180 minus B. And this is because if A greater than B, then the complement of A is less than the complement of B, so that's where the times 2 comes from on the left. If you rearrange the second equation, you'll get 2A minus B equals 180. And we get A equals 5B over 4 by the first equation. If you plug this in, you'll get that 3B over 2 equals 180. So that means B is equal to 120. And A is equal to 5B over 4, which is equal to 150. And the sum of 120 and 150 is 270, so that's the answer. Number 8, what are the tens digit of 2015 to the 2016 minus 2017? So essentially we want this expression mod 100. And so for this first term, the second term is easy to compute mod 100. But the first term is essentially 15 to the 16 mod 100, since the 2015 is the same thing as 15 mod 100. So I know the powers of cycle, or I know the powers of 15 cycle mod 100. They go 15, then they go 25, 75, 25, 75, and so on. So if n is even and positive, then it's equal to 25 mod 100. So we can just replace this with 25 since 2016 is even. 2017 mod 100 is just 17. So that means this is 0.8 mod 100, and that's equal to A. Number 9. All three vertices of triangle ABC lie on the parabola defined by y equals x squared, with A at the origin and BC parallel to the x-axis. The area of the triangle is 64. What is the length BC? So essentially we have this parabola over here. We have A at the origin, so that's 0, 0. And let's just say B is at point, let's say D and D squared. And then C is at point, since it's parallel to the x-axis, C is at point negative D, D squared. So the area of this triangle is 64, and that's just base times height over 2. The height is equal to D squared, and the base is equal to 2D. So D squared times 2D over 2 is equal to 64. So that means D equals 4. We want the length of the base, which is BC, which is equal to 2D. So 2 times 4 is equal to 8, and we're done. Number 10. A thin piece of wood of uniform density in the shape of an equilateral triangle with side length 3 inches weighs 12 ounces. The second piece of the same type of wood with the same thickness, also in the shape of an equilateral triangle, has side length 5 inches. Which of the following is closest to the weight in ounces of the second piece? So essentially, since they're uniform density and they have the same thickness, that means the ratio of their areas is equal to the ratio of their weights. So that means 12 over x is equal to the ratio of the areas, which is just the ratio of their side length squared. So that means x is equal to 300 over 9 after simplification. That's equal to 100 over 3. That's equal to 33.3 about, and that's equal to D. Number 11. Carl decided to fence in his rectangular garden. He bought 20 fence posts, placed one on each of the 4 corners, and spaced out the rest evenly along the edges of the garden, leaving exactly 4 yards between neighboring posts. The longer side of his garden, including the corners, has twice as many posts as the shorter side, including the corners. What is the area in square yards of Carl's garden? So I'll put his garden over here. And essentially, this longer side has 2x posts, including the corners, and the shorter side has x posts, including the corners. So that means there are x minus 2 excluding the corners, and 2x minus 2 on the longer side, including the corners. And then we have x minus 2 over here, and 2x minus 2. He uses 20 fence posts in total, so the number of fence posts here is equal to 20. So that means the sum of the number of fence posts is equal to x minus 2, plus 2x minus 2, plus x minus 2, plus 2x minus 2, plus the 4 corners, which is equal to, 6x minus 8 plus 4 is equal to 20. So that means x is equal to 4. If x equals 4, then this side length essentially has 8 fence posts, including the corners. And this side over here has 4 fence posts, including the corners. So this longer side length is equal to 4 times 8 minus 1, which is equal to 28. Since if there are 8 posts, then there are 7 gaps. And the shorter side is equal to 4 times 3, since 4 minus 1 is 3, is equal to 12. So the longer side is 28, the shorter side is 12, and the area is equal to 28 times 12. 28 times 12 is 336, so that's the answer. Number 12. Two different numbers are selected at random from 1, 2, 3, 4, 5, and multiplied together. What is the probability that the product is even? So, essentially, the probability that the product is even is 1 minus probability that it's odd. And odd is easy because the only reason why it would be odd is if both numbers were odd. So this is equal to 1 minus 3 choose 2 over 5 choose 2, since we're choosing 2 different numbers. And that's equal to 0.7. Number 13. At Megapolis Hospital one year, multiple birth statistics were as follows. Sets of twins, triplets, and quadruplets accounted for 1,000 of the babies born. There were 4 times as many sets of triplets as sets of quadruplets, and 3 times as many sets of twins as sets of triplets. How many of these 1,000 babies were in sets of quadruplets? So, we essentially have, if we have A twins, B triplets, and C quadruplets, we have this equation since there are 1,000 of those. And there are 4 times as many sets of triplets as sets of quadruplets, so that means B is equal to 4C. 3 times as many sets of twins as sets of triplets, so A equals 3B. Subbing in B equals 4C, this is equal to 12C. Now we just plug these back in, since we want the value of C, but we're not done after that. So, if we put this over here, then we have 24C plus 12C plus 4C equals 1,000, and that gives C equals 25. But before putting 25 for this problem, we have to see how many of these 1,000 babies were in sets of quadruplets. So there are 25 sets, but there are 25 times 4 babies in them, so there's 100 babies in these sets of quadruplets. Number 14. How many squares whose sides are parallel to the axes and whose vertices have coordinates that are integers lie entirely within the region bounded by the line y equals pi x, the line y equals negative 0.1, and the line x equals 5.1. So this is a pretty involved problem, and we'll probably have to create a sketch of the graph first. So essentially the line y equals negative 0.1, that doesn't contain any integers less than 0. So we can just replace it with the line y equals 0 and essentially get the same result because we only want squares on lattice points. The line x equals 5.1, that's also doesn't contain anything greater than 5. So we can replace it with x equals 5. So this is essentially 5, 0, this point over here. And we have this other line y equals pi x, so that goes like this. So this is y equals pi x. And it meets here at 5, 5 pi. And it meets the origin at 0, 0, obviously. So we want to find the number of squares whose vertices are parallel to the, or whose sides are parallel to the axes and whose vertices have coordinates that are integers. So essentially we can do cases on the side length of the square. So the side length was 1. So first let's just map out these heights. This would essentially be 1 pi. But we can't have anything over 3 here. So it's just 1, 3 because that's the stuff that we care about. This is 2, 6. This is 3, 9. This is 4, 12. And this is essentially 5, 15 for all practical purposes. And if you had a number greater than 5 here, then you'd have to put it essentially floor of x pi. And the floor of x pi for the first 5 integers is just 3x, which is nice. So if the square side length was 1, if you put it at 1, 0 and let it extend, then there would be 3 over here. And if you started it at 2, 0, then you could have 6 squares like this, because 2, 0, 2, 1, 2, 2, all the way till 2, 6. And then if you put it at 3, 0 to 3, 9, there's 9. 4, 0, 4, 12, there's 12. And 5, 0 to 5, 15. You can't do that because then if it started at 5, the x coordinate, that means the y coordinate would, or the second x coordinate would be a 6 if we're extending the square, right? So this is the number of squares that have side length 1, which is equal to 30. The number of squares that have side length 2 is equal to you take 1 minus each of these. So this is just 2 plus 5 plus 8. We don't include the 12 here because if it started at 4 and it extended 2 units to the right, that's already greater than 5, so we can't have that. And since it goes 2, we can only do 1 less than what we had before. So this is equal to 15. And if the side length was 3, then essentially we chop off this 8 and we subtract 1 from each of these. So for 3, it's equal to 1 plus 4, which is equal to 5. And then we'll chop off the 4, and then the 1 goes to 0. So there's no squares with side lengths greater than or equal to 4 that lie within this region. So we just have to sum these up. 30 plus 15 plus 5 is equal to 50, and that's our answer. Number 15. All the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 are written in a 3 by 3 array of squares, one number in each square, in such a way that if two numbers are consecutive, then they occupy squares that share an edge. The numbers in the 4 corners add up to 18. What number is in the center? So we put these 9 numbers in a grid, and we just want to find a nice way to make it such that the corners add up to 18. And basically, it doesn't really matter where 1 starts. So like, it does matter where 1 starts, but 1 starting in any of these side squares is the same thing as any other side square, and then 1 starting in any of the corners is the same thing as any other corner, and 1 starting in the middle is the same thing as any other middle. And so you can test all 3 cases, but I'll start with the corner case since that looks nice. So we have 1 and then 2. Let's put 3 over here. 4, 5, 6, 7, 8, 9. And that doesn't work, so we'll have to look for another configuration. So if we put 4 over here, and then 5 over here, and then 6 over here, and then 7 over here, and then 8 over here, and then 9 over here. Does that work? Well, yeah. 1 plus 3 plus 9 plus 5 is equal to 18. So that means the center square is equal to 7 here, and that answer is C. And for these types of problems, you just have to play it around. You just have to play with them a bit. It's a number 15, so it's not really that hard. You just have to play with it a little bit, and then you'll find the solution. So next problem. The sum of an infinite geometric series is a positive number s, and the second term in the series is 1. What is the smallest possible value of s? So essentially we have a plus ar plus ar squared all the way till infinity is equal to s. And the second term in the series is 1. So ar equals 1, so that means a, or r is equal to 1 over a. And the sum of this, by the formula, is just a over 1 minus r. So that's equal to a over 1 minus 1 over a, which is equal to a squared over a minus 1. So now all we have to do is minimize this quantity. And to minimize this quantity, you could use calculus, but that gets pretty bashy. So there's actually a nicer way to do this. So a squared, it's minus 1 is equal to a minus 1 times a plus 1. So that means a squared is equal to a minus 1 times a plus 1 plus 1. And if you sub that in over here, then this resulting expression is equal to a plus 1 over a minus 1. And this is equal to a minus 1 plus 2 plus 1 over a minus 1. And by AMGM, a minus 1 plus 1 over a minus 1 is greater than or equal to 2. So it's 2 plus 2 essentially, which is equal to 4. So 4 is the minimum value of S, and so that's the answer. Number 17, all the numbers 2, 3, 4, 5, 6, 7 are assigned to the 6 faces of a cube, one number to each face. For each of the 8 vertices of the cube, a product of 3 numbers is computed, where the 3 numbers are the numbers assigned to the 3 faces that include that vertex. What is the greatest possible value of the sum of these 8 products? So, essentially, if you look at this cube, let's try to just label it arbitrarily. So, if we put A at this face, then B at this face, and C at this face, then D at this face, and E at this face, and then F at this face, where E and F are the protruding faces into the page and out of the page, and then A, B, C, D is that kind of cycle. Then basically the product over here at this at the top right vertice that I'm hovering over is equal to ABF, and the product at the bottom, the product at the top left vertice, the one that I'm hovering over right now, is equal to ABE. And so the sum of these two is equal to AB times E plus F. And then the sum of these two over here, the one that I'm looking over right now, is equal to ADF plus ADE. And that's equal to E plus F times AD. And the product of the two bottom ones over here is equal to FCB, so BCF plus EBC, so BCE. So this is equal to E plus F. And notice how I'm factoring out the E plus F in all of these. And then the ones at the bottom right, or bottom left, and bottom left top is equal to CDF plus CDE. So CDF plus CDE, that's equal to E plus F times CD. So if we add these all together, then we'll get the expression that we want. And essentially this factors into A plus it factors into A plus C times B plus D times E plus F. So essentially the things on the opposite sides basically are in the sum of the product. And so we want to maximize this expression, and we have that they take the values 2, 3, 4, 5, 6, 7. And so essentially the maximum occurs when all of these are equal, and you can prove this by AMGM. So you would have 2 and then 9 minus, or you would have x and then 9 minus x for these pairwise products, or pairwise sums. This is 2, 7, 3, 6, 4, 5, and that's equal to 9 cubed, so that's equal to 729. I know this isn't a very complete explanation, but it's just like how you would go along doing this. So number 18, in how many ways can 345 be written as the sum of an increasing sequence of 2 or more consecutive positive integers? So essentially we have to have a plus 1 all the way till a plus n for some n is equal to 345, and there are n plus 1 terms in this product, and then there are the average is equal to 2a plus n over 2, so this is equal to 345. And then rearranging this, we get that n plus 1 times 2a plus n is equal to 690. So if 2a plus n is greater than n plus 1, then we'd have 2a greater than 1, and so a greater than 1/2, right? But if 2a plus n is the smaller term in this product, that means a is less than 1/2, but they're all positive. So we need all of these terms, so essentially this always has to be the greater term. And that means the number of factors that work are equal to the number of factors of 690 over 2, since half of them are greater than the square root of 690. So 690 is equal to 2 times 345, which is 2 times 3 times 23 times 5. So over 2 is equal to 3 times 23 times 5. The number of factors of that is equal to 8. But the only case we're essentially missing is when, or essentially that we're overcounting is when n equals 0. Because then this would be 345 and 1. But if n equals 0, then that wouldn't work out. So since we need at least 2 or more consecutive positive integers, so we minus 1 from this and we get 7 as our answer. Number 19, rectangle ABCD has AB equals 5 and BC equals 4. Point E lies on AB such that EB equals 1. Point G lies on BC such that CG equals 1. And point F lies on CD such that DF equals 2. Segments AG and AC intersect EF at Q and P respectively. What is the value of PQ over EF? So in these problems, you always want to extend the segments that you're given to get similar triangles. So if you extend this, we have this is 1, this is 3, this is what, 4, this is 1, this is 2, and this is 3. And this triangle, let's call this point X. XGC is similar to XAD, so that means XC is equal to 5 over 3 by this similar triangle, since it's equal to 4. And so that means this over here, FX is equal to 14 over 3, and AE is equal to 4, and triangle FQX is similar to AQE. So that means essentially that QE over FQ is equal to 4 over 14 over 3, which is equal to 6 over 7. And now I'll just call these things by their variables. So I'll call PF equals X, PQ equals Y, and Q equals Z. So essentially this means that Z over X plus Y is equal to 6 over 7. But we also have another pair of similar triangles. We have that FPC is similar to APE. So that means PF over PE is equal to 3 over 4. That means X over Y plus Z is equal to 3 over 4. And so if you want to solve these equations, you want to find everything in terms of Y. So this second equation gives you that Y is equal to 4X over 3 minus Z. If you plug this into the first equation, then you'll get that 6X plus 6Y equals 7Z. And you have Y is equal to 4X over 3 minus Z. So if you sub this in, you'll get 14X is equal to 13Z. So Z is equal to 14X over 13. And so if you sub that in over here, then you got Y is equal to 4 over 3 minus 14 over 13 times X. That's equal to 10 over 39 times X. And so you want to find PQ over EF, which is Y over Y plus X plus Z. That's 10 over 39 over 10 over 39 plus 1 plus 14 over 13. That's equal to what? 10 over 92. So that's the 10 over 91, sorry. So that's the answer. I'm going very fast on these computations because I don't have much time left. Number 20, a dilation of the plane that is a size transformation with the positive scale factors and the circle of radius 2 centered at A 2 2 to the circle of radius 3 centered at A prime 5 6. What distance is the origin 0 0 move under this transformation? So essentially, a circle of radius 2 at 2 2 gets mapped to this point 5 6. And this circle is of a radius 3. So that means if you transform it, dilate it from this point X, so this is A and A prime, that means XA over XA prime is equal to the ratio of their radii, which is equal to 2 over 3. And AA prime is equal to 5. That means XA is equal to 10. And you have to find the value of XO. And you have to, this goes to O prime. And you want to find the length of O prime. So we can just use coordinates to find the value of X. So this is 2 2. This is 5 6. Then the value of X is equal to negative 4, negative 6. And so that means XO is equal to root 52. And OO prime, since this is a transformation, OO prime is equal to root 52 over 2. As we saw here, AA prime is equal to XA over 2. So OO prime is equal to XO over 2. And root 52 over 2 is equal to root 13. So that's our answer. 21. What is the area of the region enclosed by the graph of the equation x squared plus y squared equals absolute value of x plus absolute value of y? So this is an absolute value problem, so you would just want to graph this out and see what you can do with it. So you have, if x and y are both greater than 0, then we have x squared plus y squared equals x plus y. And that simplifies to a circle with radius 1 or root 2 over 2. Because if you simplify this, then you'll get this is equal to 1/2. So the radius is root 2 over 2. And it's centered at 1/2. So it kind of looks like this. And then the circle, there's a circle over here. It's essentially just 4 copies of the circle. So they all look like kind of like this. And then you have a circle over here. Then you have a circle over here. So something like this. And you want to find, so none of these like overlap with each other. So you want to find the area of the whole thing. So it's just the area of the 4 circles minus the area of the overlaps. And you can actually use, these are basically loops, so you can use geometry to find the area of an overlap. So this radius is root 2 over 2. So that means this area of the triangle is equal to 1/2, but the area of this sector is equal to pi over 8. So one of these small half overlaps is equal to pi over 8 minus 1/2, or minus 1/4. And you multiply this by 8, since you have 8 small sectors equals 4 overlaps. That's equal to pi minus 2. So that's equal to area of the overlaps, so we just have to subtract this from the area of the 4 circles. The area of the 4 circles combined is equal to pi over 2 times 4 is equal to 2 pi. So 2 pi minus 2 is equal to pi plus 2, and the answer is B. Number 22, a set of teams held a round robin tournament in which every team played every other team exactly once. Every team won 10 games and lost 10 games. There were no ties. How many sets of 3 teams A, B, C were there in which A beat B, B beat C, and C beat A? Okay, I'm not gonna go through the combo solution here. I'm just gonna go through the quick solution that you should do. So you have 3 sets of 3. You have sets of 3 teams, and essentially, or the only way where it succeeds is if you have this sort of cycle, A to B to C. So the probability that this cycle occurs, there are 8 essentially ways for you to assign these directed paths, and only 2 of them result in a cycle. So 2 over 8 are approximately cycles, so approximately 1/4 of these are cycles. And there are 21 teams in here, so 21 choose 3 times 1/4 is going to be a bit less than the answer. It's an underestimate. And I believe this is like 1330 over 4, which is like 332.5 or something. So the closest answer to that is A. Okay, I had like 1.5 minutes left to do 23, 24, and 25, so I just decided I wouldn't have enough time to do any of these 3. But if you wanted the solution outlines for each of these, 23 is you just draw the segments in, and then use the fact that they're equally spaced apart to basically just use complementary areas, and you should get 11 over 27. 24, you just do a lot of casework, I guess, and you get 17. And 25, if you do some manipulation, the sum basically and some other like insights, then the sum collapses to phi of 10 plus phi of 9 plus all the way to plus phi of 2, which yields, I think, 32. But yeah. So I didn't do 23 to 25, so that's the same thing, I guess, as leaving it blank. So this is like, I think I got the first 22 correct. So I guess this is sort of like 136.5. But, so yeah. I'm sorry I couldn't get through all the problems. Reading is kind of hard when you're reading all these problems. But if you want us to do this next time, or if you want us to do this another time for maybe Amy, like 7 Amy, or like the first 10 Amy problems in half an hour or something, or you want us to do this for another AMC, please let us know, and tell us which test you want us to do it on, because we'll try to do it. So thank you for watching. If you enjoyed this video, please like and subscribe, and let your friends and family know. The AMC is in like 2 days, so you should probably, we have a lot of other videos for AMC, so if you're doing mocks and you're unsure about how to solve a problem, then we have a lot of problems already on videos. So go check those out if you haven't already, and thank you for watching.